So welcome and thank you for joining. Today we're going to discuss a challenge I think all of us can relate to, especially if you work in a manufacturing plant: procedure clarity and flawless procedure execution. So we're going to break this into three buckets. The first being, how can you ensure procedures are clear and concise? The second, how can you visualize the procedure steps in the field? And lastly, how can you practice them so they are executed in a standard and correct way? So joining me today is our Director of Operations, Fran Montemuro. He is our in-house expert. He spent over 30 years in manufacturing, plant manager at multiple DuPont sites, and an awarded operations leader. And myself, Christian McDermott, North American coordinator for Vuvio, and my expertise lies in more of the technology side. So it's well documented that unplanned events in manufacturing could have been prevented if procedures were executed properly. Failure to follow procedure is often cited as the root cause in incident investigations. However, here at Vuvio, we looked at data from across North America, which you'll see in a minute, and we think procedure clarity is a major source of execution error in the field. And here the ASM consortium, which is the Abnormal Situation Management Consortium, it's a group of leading manufacturers and universities. They identified three main groups of causes of abnormal events. And the first being that the procedure was not followed. The second, procedure was wrong. And the third, procedure not followed correctly. Now, we believe this assessment is valid based on our own research and data, which shows that procedures are often, full of ambiguity and lack of clarity. So I'm going to pass it on to Fran to continue the discussion.
Okay, thank you, Christian. So let's first talk about procedure clarity and what that means for an operator. So as Christian mentioned earlier in the introduction, we break it down into three steps: clear and concise actions. So there's a lot of companies out there going out, rewriting procedures and making sure that they capture all the steps in the procedure. But we believe that only accounts for one of the three aspects required to make a procedure clear and concise for the operator. That's the words. The other piece is the ability for the operator to visualize that step in the field. Being able to visualize it brings that ability for them to understand how that procedure should occur. And then lastly is their ability to practice or learn by doing that procedure as they execute it in the field. So we believe all three of those components bring procedure clarity to that individual operator. So as Christian mentioned, we did an analysis. We randomly sampled about 300 procedures from across North America, and we analyzed those procedures. On the screen on the left-hand side is a breakdown of that analysis. Majority of those procedures were startup and shutdown procedures. And 90% of the procedures we analyzed were SOPs that contained ambiguities or generalities. And I'm going to talk more about that. But to understand why procedure clarity is so important, we identified two reasons for suboptimal clarity. One is the procedure does not reflect the practice that is going on in the field. Across many units and many plants, operator practice does not match procedure, and in some cases it varies from shift to shift within the same unit. That's one piece. The second piece, as I mentioned, is the ambiguities and generalizations. So these procedures are written with the belief that the operator or the person executing the procedure understands what it means to close all the bleed valves, etc. So to that point, I have a couple examples. This one case is somewhat extreme, but it drives home the point. The procedure line item stated, it's written at the top there in step 1, and the intent was for the operator to use 70-pound nitrogen to purge all the equipment, process lines, etc. When our engineers, the Vuvio engineers, walked that procedure with the resident subject matter expert and asked that subject matter expert how to execute this one line item, we ended up documenting 112 actions that the operator needed to do to satisfactorily meet the intent of that one step. Another example, it's probably more typical, is on a reactor in which the reactor needed to be flushed and all the components around that reactor needed to ensure a good flush took place to prevent a reactor poisoning event. And in this case, again, when we walked that procedure with the resident subject matter expert, 53 actions were documented, and it involved the operator going and having to actuate 15 different valves. So again, ambiguity and generalizations are a significant component causing a lack of clarity in operations. So why is clarity important? Well, clarity leads to understanding, which leads to competency. And what this chart shows on the y-axis is operator competency over time. Traditional methods of onboarding, training, and qualifying operators involves reading procedures and on-the-job training or job shadowing. With Vuvio, the ability to take an action checklist, tie it to a visual or a digital replica, and create the simulator for the operator to practice that procedure repeatedly without having to depend on the availability of the SME, and then test that competency using a standardized test. We've seen 100% competency gains with the operators and productivity improvements up to 50%. So with that, I'll turn it over to Christian, and he'll cover the Vuvio demo.
Thank you, Fran. So I'm just going to share my screen here. And Fran, can you just let me know if it's appearing on the view?
There it is.
So, okay, so hopefully everyone can see my screen now. I'm sitting remotely using my laptop. Everything I'm about to show you, of course, is going through this conference platform. So it might appear a little bit jerky, but in reality, it's very smooth. So what you're looking at is a procedure simulator. And this is important to kind of understand those 3 points that we made earlier. You know, how you can have clear and concise actions, the ability to visualize your procedure steps in the field, and the ability to practice, basically learn by doing. So on the screen, you have a simulator. On the right, where my mouse is waving around, that is the digital replica. So this is the real view plant, or real view of the plant. And this is where you can interact with the equipment and execute the actions that you see here on the left-hand side. You also have a map at the bottom here, so you can always see where the equipment is located and where you are standing. On the left is your procedure document. So this is the manufacturing plant's own document, its own words and all of that. So this is exactly what the operator would be using. Above that, we have this action checklist. And now this is exactly what Fran alluded to. So because we're simulating every single action in each procedure step, so for example here, open the condenser water box vent valves. It doesn't actually say how many there are. And some procedures, as you've seen, a lot more vague. Here, for this step, we have 4 actions, and they're 4 different valves. And here you have the valve names as well. And this is where we can now interact with the equipment here in the replica on the right. So I'm going to open the second valve here and confirm I've done it. And you'll see that you have that clear and concise action-based step, and it's mapped to the real plant. And this simulator that I'm showing you is called a guided simulator. So that means it's like a virtual SME, a virtual subject matter expert, walking you through the procedure. So right now it's walking me to the next step, to the next valve, and it will instruct me when to interact and what to do. We have a few different versions of this simulator, and I'm just going to show you this one, which is not guided. So I can actually drive myself around, and you can now execute this procedure, and it will tell you if you're going wrong or not. But I'll do the first step here. And this is truly learning by doing. So I'm going to take this valve and close this valve as per the action checklist instruction. Confirm, and it will now move to the next step here in the procedure and the action checklist. The other thing about having a simulator and mapping your procedure actions to the real plant is you can also use it for knowledge capture and transfer, things that are not in the procedures. For example, here we have a knowledge snippet, which is basically telling me why this valve is always left open. It could be a video, or it could be something else to explain how to do something or why you're doing something, cautions or notes or anything like that. So highly effective knowledge transfer tool to really get the right information to the operators. So the learn by doing is really key. So hopefully we've explained how you can have clear and precise actions, concise actions, and learn by doing as well. But what about the ability to measure competency? So being a simulator environment, you also have the luxury of being able to test and get immediate feedback on everything you're doing. So in this simulator, it's the same layout, but here you'll see as I execute the first step, and I'm going to walk down here and close that valve, you'll see that we get immediate feedback in the left in the form of this report, which says I got this action correct. So if I make a mistake, so let me walk down here where we were earlier, and I'm going to crack open this valve and confirm. And you'll see it says action not completed correctly. It even maps and tracks the valves or the equipment that I've been interacting with. And being a simulator, you have the opportunity to try again. So that's what I'm going to do. And you'll see that when I do this step correctly now, I get that immediate feedback, and it's actually tracked that I got it right after 2 attempts. So this is a way of not only learning your procedures in a very visual way and learning by doing, but also measuring the knowledge and competency of procedures. And you get a report at the end of each test, which is linked to your operator name, and it's a detailed record of everything I did. So you have a good snapshot view of competency levels in procedures, in your critical procedures, or wherever. So everything we've just shown is about building competency and ensuring procedure clarity. But what about using something in the field when you're actually performing a procedure? So this is an example of a field execution tool. and this would be utilized on a tablet or a mobile device. You have your action at the top. So this is the action you need to perform, and it's combined with the image from that digital replica we showed before. So you can see where this piece of equipment or this valve is located. And if you need to toggle between that detailed view and the pathway view, it's just a click of a button. So very, very user-friendly. And those knowledge snippets that we talked about are also available, again, at the click of a button. So operators have all the information they need at their fingertips. There is also a note-taking capability as well, but importantly, it's a visual aid for the operators in the field. And the output of this, similar to the test report, is some data which is stored in the cloud and provides a snapshot of this procedure execution, including any notes. So with that, I'm going to turn it back to Fran, who's going to continue the conversation.
Okay, Christian, before you come back to me, can you go to the guided module? It'll help me with my next chart. What I'm going to show next is some data we've collected looking at the left side of the screen. The top left of the screen is the action checklist that we create during our line walk. The bottom left is the customer's procedure document. So with that, let me go ahead and show my chart, and there we go. So what this chart shows is data we've collected over several projects. On the left side is the number of procedure lines or procedure steps, and the bars, the blue bars, are the number of procedure lines that the customer procedure has. The orange bars are the number of action steps that are then created after the line walk. So as I pointed out in the Vuvio guided module that Christian had pulled up, if you look at the first set of bars, this procedure had 25 procedure lines, but by the time we completed the line walk with the subject matter expert, it had 117 or 118 actual action steps. So again, as we talked earlier, that's the first step in creating procedure clarity, are clear and actionable steps for the operator. And as we talk more about clarity, when an operator is qualifying on a job, they read the SOPs. Traditionally, we find they job shadow for a couple months. They do field walkthroughs, and then they sign off that they've been trained or qualified. And usually, the SME, the trainer, the learning coordinator will sign them off as completing their qualification. However, there's been data gathered in industry by some of the folks like McKinsey's, et cetera, that show that they only qualify on and actually experience about 40% of the procedures that they qualify on. And that's because equipment is just not available. It's running, it's in operation. The unit cannot afford to shut it down just to qualify operators. So they never truly experience the actual startup, shutdown, et cetera, procedure that they are signing off on. So with that, they truly do not have not demonstrated their competency or demonstrated understanding of that procedure. Again, that's the visual side, being able to visually see the procedure as well as demonstrate the competency by working through a simulation that is provided using Vuvio. So we've received feedback. After every project we implement, we ask for operator feedback. And in the surveys that we've conducted over the last 3 years, we've had all the operators respond that they strongly agree the procedure simulators make it easier for them to learn and understand their procedures versus their traditional methods of just reading the written word. The simulators provide clarity to how to perform their job in ways that they have not been able to understand or see in the past. And then lastly, it increases their ability for procedure compliance. The compliance, we believe, has to do with the standardization that is provided with simulating these procedures. It eliminates one shift performing a procedure differently than the next shift, one operator doing it differently from the next operator. Because when we conduct the line walk, we create the action checklist tied to the digital replica with the visuals, and they all practice the same standardized procedure. So to wrap up, procedure clarity, I'll call it VUVIO clarity. And the way we achieve clarity is 5 simple steps. It's the line walk with the subject matter expert. We create the actionable checklist for every action the operator is expected to perform in the field. Generate the digital replica, so brings the visualization, the visual component of the field to the operator. And then once we can tie that checklist with the visual aspect of the field, they can then move to practice and refresh the simulations. They can practice to a point of competency where they can take a test. And they can also practice just prior to execution in the field, and we call that the refresh prior to execution. And then when they go to the field, they do have the ability to use the field execution tool in the field on a tablet just to ensure that the procedure is executed as planned. So with that, before I go into the case studies, why don't we open it up and see if there's any questions?
Great. Thanks, Fran. We do have a question here, so I'll get right to it. Is special infrastructure, for this kind of solution?
I can take that one. There is no special infrastructure is needed. Everything we've shown you is cloud hosted. So there's no IT involvement. It's just if you wanted to use it in the field, then you would of course need some kind of tablets. But yeah, no special infrastructure required.
Great, thank you. And the next question we have is, the simulator example used existing OPs and plant/equipment. Please describe how your tool is used to train operators for new facilities.
So Christian, I'll take that. So yeah. Similar, we would work with the customer on understanding and reviewing those procedures, and our turnaround time is typically 14 to 16 weeks. So for a new facility, the mechanical completion usually is in front of startup several months ahead of time. So we could work with that customer, do a photo shoot, do the line walk, and capture the action steps prior to commissioning and startup, and deliver that project in a like I said, 12 to 16 week time frame, so they could have it for startup. So we'd follow the same process. We would probably come back after startup, after the procedures are redlined, and then update our simulators.
Great. Next question we have is, do you have any examples of how this actually stopped errors in the field?
We do, and I'll actually cover some of that in our case studies, but the biggest finding is reduction of unplanned events, giving the operator the ability to complete startups, equipment turnarounds or swaps effectively and efficiently by calling out each actionable step. And we even have examples where we're eliminating reportable environmental releases just because we're identifying every valve that needs to be closed prior to startup or shutdown and prevent that environmental release. But yes, we'll cover some of that in our case studies.
Great. Next question is, Do you have to do yourself every procedure tailor-made to customers, or do you train IT personnel to use your tools?
I can take that one, Fran. So we send in what we call forward engineers. They're very efficient. They have an industry background as well, and they walk through the procedures with the subject matter experts. So we very much help build everything you've just seen in a very short amount of time. So it helps, minimize the time that the plant needs to dedicate to this, which is not very much.
Great. And the next question we have is, do the visuals from the interactive tool need to be updated every time there is a change to the facility? Even with routine maintenance, it seems that equipment can visually change a lot over time.
So yeah, I'll take that, Christian. So to me, whenever I was in industry, I wasn't a huge fan of simulators because they were very difficult to maintain. However, with Vuvio, these are digital pictures that our customer, if they're a simple change to a component, our customer can take that picture, send it to us, and we'll turn that around quite efficiently and update the replica. If there's a significant change, a bypass around a piece of process equipment, et cetera, our forward engineers can get in, take those necessary pictures, and update the replica. But updating the replica is quite simple with Vuvio because we're taking digital pictures and then replacing them in the existing replica.
Great. Next question. Can the procedure execution be seen represented with a dynamic process flowchart?
Fran, do you want to take that one?
Yeah, so a dynamic process. So we're not a dynamic simulation. We're offline simulating. We can simulate process flows. We can simulate DCS movement, but we're not simulating anything dynamic. So we're not going to show the results of a pressure increase. We can if the SME tells us what output they want to see on the screen, then yes, we can simulate that. And again, we can simulate process flows in our enhanced views. So we will work with whoever asked this question to ensure that we can simulate what they're after, but it is not dynamic simulation like a DCS simulator.
Great, thank you, Fran. Next question is this a classroom solution or could be with operator on shop floor? Time to develop it is a matter of resources.
Oh, Christian, I'll take it. So it's every aspect of qualification for an operator. It's onboarding a new operator. It's a great classroom tool for process overviews. It's a great tool in the field. It's a tool that operators are using just prior to going out in the field and executing. And then it's a tool for recertification. So it covers all 5 phases of training for that operator, whether they're experienced or brand new. And then as far as matter of resources to implement, Vuvio is very resource light for the customer. We come on site, we need 3 to 5 days of the subject matter expert to do the photo shoot, do the line walk, and then we disappear. We go away for 12 to 14 weeks. Over that 12 to 14 weeks, we will reach out to that SME for maybe 2 to 3 hours, 2 times. And that's following the standard project process where we want to do check-ins to validate the data and the production that we're doing is accurate. And then 12 to 14 weeks later, we deliver everything that you've seen. Well, you haven't seen everything. We even have a assign and assess module, et cetera. But we deliver everything, and we'll coordinate with the site to train all end users.
Great, thank you. Next question is, can existing point cloud data, for example in digital twins, be used to prevent the need for additional photo shoots?
I can take this one, Fran. So yeah, Vuvio, our digital replica is very different to what you would call a digital twin, and they're two totally different technologies serving two different purposes. So that's an important point to make. But in terms of updating, Vuvio was specifically created for the manufacturing environment, and the raw material we use are photographs, JPEGs, basically, and so that allows us to keep the replicas up to date with changes in the field very, very quickly and very efficiently. With scanning, it's much more complex, requires a lot more time and resources, and the cost is just not feasible to maintain it on that kind of frequency. Whereas dealing with digital replicas and single images, it's very easy. And Fran mentioned in one of his answers that we've had customers send us pictures which we can refresh very, very quickly. So yeah, point cloud data is something totally different. I think we'll probably have to go to the case studies, Fran.
Okay, I can do that. So 3 case studies, and just want to hit the high points of how valuable procedure clarity or clarity for the operator is in the industry. In this example, we had a petrochemical plant that was experiencing a lot of yield loss, non-standard production after a startup of one of their major pieces of equipment. We went in and did a project, and some of our findings there was the shift-to-shift variation on how to start up the equipment. So practice did not match procedure. With Vuvio, we were able to go in, create that detailed action checklist, marry that to the visuals on the components, and then provide a simulation that the operators could then practice prior to startup. They were using generic P&IDs and expecting the operators to use those P&IDs to start up the equipment. And the operators were just struggling getting the consistent execution when starting up the equipment. This team also was able to use our field execution tool on a tablet in the field to assist in their startups. The next one I wanted to cover, and I think I touched on this earlier, is we had a refinery that was having some issues with loss of containment of their process materials. What we found here was a classic example of ambiguity and generalizations. There were several references to closing all the drain valves, isolating equipment, but it did not provide the operator with the detail required for them to ensure effective execution. So we went in, detailed, created the action checklist, provided the visuals for the components, and a combination of practicing prior to execution as well as taking the field execution tool into the area and confirming the procedure was done correctly, helped them prevent additional environmental releases. And then the last one I wanted to cover, I see we're at our end of time, is we have a customer that was, I won't cover their turnover challenges, but it was more around having unplanned boiler feedwater pump shutdowns. This was causing issues with their uptime for the unit. And in this unit, since they're supporting a major refinery, uptime is critical. So we went in, created detailed checklists, allowed them to refresh prior to execution, and then they were able to go out and execute the boiler feed water pump swaps without fail. That's all I have.